Hello everyone, my name is Steve Scully, and in this video I would like to explain to you the structure of the universe. I understand that this video is long, but I hope that you choose to watch the whole video and come to understand the universe fully, because it is possible for us to now move forward beyond the material world and into deeper understandings when it comes to life, what we are living for, and beyond. So the model of the universe that should explain it in its entirety should be one that is simple and elegant. The universe should not be complicated. As Einstein said, I have a deep faith that the principle of the universe will be beautiful and simple. So a physical theory of everything, one that explains all that is simply and elegantly, it should also coincide with one that is philosophical, a philosophical theory of everything. So in order for us to find the proper model, we must first base that model in logic, in what the universe should be like, and then we can show how the model that we have come to realize matches all observations from the microcosm to the macrocosm, all observations big and small, and thereby confirming what I call the universal principle of natural philosophy. So we'll start by looking at the Big Bang so that we can come to understand why the Big Bang is the current model, and in understanding such, we can find the holes, the errors, and the mistakes that were made with the model. So before the Big Bang was the model, the universe was considered to be infinite and eternal in existence, always is, was, and forever will be. However, then when the Big Bang came to be, then there was a beginning in the concept of the universe. And so this change in philosophy comes down to one observation. So in the early 20th century, when the telescopes became strong enough so that we could see distances that we just simply couldn't see in the past, we progressed out of our Milky Way galaxy to finally escape into the beyond with the discovery of other galaxies. And when we started to analyze the light spectrum of these galaxies, we observed that galaxies at a certain distance, all around us in all directions, had their light spectrum redshifted in all directions. And so this is the actual observation that led to the Big Bang. So what this observation means is that locally we will observe certain absorption lines dependent on what molecules and atoms, etc., are in the light absorbing radiation, thereby absorbing at certain wavelengths. We will observe this locally at specific wavelengths. But then when the light has traveled certain distances, sufficient distances, that the galaxies are all redshifted, what occurs is the absorption lines are shifted towards the red spectrum as this. So the same pattern exists. It's just shifted towards the red spectrum. And so this is what a redshift is, and this is what we are actually observing. We're not observing some explosion. This is what we observe. And so the history of the interpretation of this observation is extremely important to understand precisely how the Big Bang has came to be the model, the standard model of the universe that it is today. Now, the reason the Big Bang came to be is because this redshift is in all directions, and so they interpreted it to be the result of motion, and the reason that is because Doppler shift works in this way, where an observer will have an object moving away from the observer, and that will produce a relative redshift in the light spectrum, and so the observer will see redshift, and they see it in all directions, and so they said this cannot be due to gravity, which can also cause redshift, but instead it is due to Doppler shift. And when they said that, when they made this assumption, which it is an assumption, when they did this, it meant that they could ultimately say, because everything is moving away, we can reverse time such that all things are back together. Thereby, there was a Big Bang. And so, this is the observation that created the Big Bang. Until this observation, there was not even a concept of this anywhere. This is the beginning of this concept. Now, the next problem they faced is that then they saw that, well, redshifts of more distant galaxies, ones that are really far away, they began to be observed to be greater than the value of 1. And so what this means in terms of Doppler shift, if it's due to Doppler shift, it means that the object is moving faster than the speed of light. And so this is breaking the laws of physics. Therefore, it cannot be Doppler shift in and of itself. There is some other cause to this. And so instead of looking at gravity again, what they did was they saw a correlation known as Hubble's law of redshift per distance, and ultimately redshift has begun to be translated into velocity due to this correlation, and then the expansion of space which they've added. And so this correlation of redshift per distance in a linear relationship is what they call cosmological redshift. And they took this and said, instead of being due to gravity, this is due to something that we have never discussed before, something you cannot read about in Isaac Newton's journals, something called expansion of space. And so philosophically they are adding to the model, and it all comes down to they made this assumption of Doppler shift that led them down this path. And so again, an assumption was made. The assumption of Doppler shift over gravitational redshift is what led to expansion of space in the model. And so Occam's razor points to a flaw in this assumption because they are adding to the fundamentals of physics by adding expansion of space. So this begs the question, could gravitational redshift somehow cause the observation of all distant redshifted galaxies in all directions? So the way that gravitational redshift works is there is a source of gravity. The light will be moving away from the source of gravity, and that will create a redshift in the light spectrum. Or alternatively, it will be moving towards the source of gravity, and that will produce a blue shift in the light spectrum. And so this is just how gravitational redshift works. How this could be is not as simple as it looks. We have to first look at the universe philosophically. So, the most important ability that we as human beings have is pattern recognition. You can understand the words I'm saying because of pattern recognition. You can see the words on the screen because of pattern recognition. You can read them. All of the understandings of all things around us come down to being the result of pattern recognition. So this begs the question, are we missing a pattern? So the first pattern I want to talk to you about is the orbital pattern. So the moon orbits the Earth orbits the Sun orbits the supermassive black hole at the center of the Milky Way. Therefore, we see a pattern of small orbits large, large orbits larger, larger orbits even larger. And so this implies that logically, philosophically, this should continue such that the supermassive black hole at the center of the Milky Way orbits something else, and that orbits something else, and that orbits something else, and this should continue infinitely. So then the structure of the universe should grow infinitely large. Now, when we remove the observer and we pretend that we do not exist because we play no role in the overall structure of the universe, the fact that we exist has no effect on the overall structure of the universe. So when we realize that, and we thereby remove the observer from the equation, and then we drop back down from the infinite. Imagine we are at the infinite, and we come back down and we try to find a base level, an elementary particle, a building block upon which the universe is built. Then we realize that just the same as over here, it should grow infinitely small towards infinitesimal. And so this is the philosophical structure of the universe using purely pattern inference. And so when we look at this, we can ask the question, well, what are photons? If this is the structure, so the structure implies that photons are the levels of the universe which we, as fallible observers, perceive as massless and having a motion that we perceive as the speed of light. But we have to understand that we are finite, fallible observers, and we can only perceive a certain amount of infinite, and any amount that is still nothing next to infinite. So the fact that we have all of the technology that we have doesn't really make us see any more of infinite. There is still infinitely more beyond what we can see. And so things that are at our limits, even our limits of machinery, of our technology, these things that are beyond those limits, we can perceive them as being massless and as traveling at the speed of light. But the speed of light is the limit of motion of matter. No matter is truly moving the value of the speed of light, in that it is essentially observed, it is perceived to be constant, because beyond a certain energy input, everything essentially travels the speed of light, the limit of motion of matter, to a finite fallible observer. But so how we observe the velocity change, because when energy is removed, there is a velocity change, but it's so minimal that we cannot perceive it. So instead, what we do perceive would be a red shift when it slows down, or a blue shift when it speeds up. Now, evidencing that photons are particles is Furstenberg et al., and in their research paper here, they ultimately remove the infinitesimal by creating a vacuum. They remove layers of the universe, and then they shine photons near a highly interactive particle. And because they've created a vacuum, they've created an environment that is more likely for them to be able to observe the mass of the photon. And what they found was that when they did this, then they could see the mass of the photon. And the reason this is because we're stretching our limits of perception even further when we do this by creating a vacuum. And so they're able in this experiment to perceive that photons do have a mass. Now, with that in mind, we want to look at the next orbital pattern. So the moon orbits the Earth in a generally circular / elliptical orbit. So ultimately, the distance that the moon is from the Earth at all periods during an orbit is generally constant. It can become closer, and we'll observe it as what's called a supermoon, or it can become further away. But ultimately, it's generally constant. It's not too close to the point where it's causing chaos on Earth. It's a generally circular / elliptical orbit. The Earth orbits around the Sun at a nearly constant radius, such that the radiation from the Sun is constant all year, just dependent on the angle that the Earth is changing seasons. So the actual distance away from the Sun is very constant, creating a circular orbit for the Earth about the Sun. And then the Sun is thought to generally be in a circular / elliptical orbit about the supermassive black hole. So what we're seeing here is that levels of the universe that are close to one another in size, they can form stable orbits that are generally at constant distances apart, such that they're not really flowing all that close to one another. But when the sizes, the relative mass differences increase, such as in a comet versus the Sun, the object in orbit can travel in a way where the distance it is separated from the object it is orbiting is extremely different at different times in the orbit, such that it's extremely far away, and then it gets extremely close, and then it goes extremely far away. And so this change in the relative distance is a stable orbit for such a system, because the mass differences are so much more substantial that the Sun can control the comet more easily, such that it's not very easy for that comet to be in a circular type of orbit. So now we want to ask the question, well, how does the infinitesimal orbit when it is in a direct orbit with the infinite? And so before we can answer that, we have to look at what's known as the neutrino. So what this image here is an observatory that is used to detect neutrinos, and it's not on the top of a mountain or in outer space like telescopes generally are. It's built deep underground, and all of these strange balls are used to direct these neutrinos into detectors. And the reason that is because neutrinos from the cosmos physically flow through the earth. And so we actually are aware observationally that the infinitesimal travels through the infinite. And so, with that in mind, the logical pattern that the infinitesimal would follow through the infinite would be one in which, even at the speed of light, it cannot escape, and it is always pulled by the force of gravity back towards the center of mass, back towards the center of gravity, and it will flow physically through the body, but then the force of gravity is behind it, and so it will bend in the other direction, creating a figure 8 flow pattern. And so this is the orbit for the infinitesimal through the infinite. This is what it should be logically, just using philosophy right now. This is what the universe should function like. So, with that in mind, we now want to visit the question, can gravitational redshift in this figure 8 pattern produce all distant redshifted galaxies in all directions? And so, dependent on the size of the infinitesimal relative to the other infinitesimal, they will have many different figure 8 flow patterns of different radii outward in this flow pattern. And it will sum up into figure 8 patterns such as these. And so, when we look at one of these figure 8 patterns, what we see is we see that it can move radially a certain distance, and then it moves radially the same distance back. And so we can separate this into vectors of equal but opposite radial motion, and then we can separate the right angle vector of the orbital motion. So at all points during orbit, it's essentially going at a right angle. So if it's at this portion of the orbit, it's going at a right angle in this way. If it's at this portion of the orbit, it's going at a right angle in this way. And so at all points during the orbit, the orbital motion will produce a portion of redshift, but the radial motion outward and the radial motion inward, the vectors will cancel. So each time through this figure 8 pattern, of this figure 8 pattern here, we'll have a canceling radial motion, but an additive redshift each time through. So redshift, redshift, redshift per distance. And so this object here, the great attractor, which I will go into why it is the object that this is doing it, this object is so massive that it is physically pulling all of the photons around it back to it, and then physically through it, because it's so massive that even an entire galaxy's worth of photons flow through without impediment, without the probability of interacting with something. Because it is so massive, the other particles are so small that they can flow through the body of mass of the great attractor. And so if there are many flows of these figure 8 patterns, not necessarily all of them would be in the same direction. It would be just random that would sum up into a general flow like this. But the possibility of ultimately galaxies arriving at Earth that is orbiting this at some distance outward of about 150 million light years away from the great attractor, this object its light could flow through the great attractor and then finally arrive at Earth, but from any angle, dependent on exactly what the figure eight pattern is and what angle it's going at. It could also be going in the opposite direction, etc. It could be going in many different ways, but it would ultimately arrive at Earth at any angle and at a constant redshift per distance correlation of Hubble's law due to this flowing through the figure eight pattern that is constantly adding a redshift. And so if we go back to this figure, as you probably have noticed, this isn't just a bunch of figure eight patterns. This is much more significant than that. This is literally the electromagnetic field of the great attractor. And so this produces one of the four fundamental laws of nature. And the significance of this is that we don't need to say that there is this causeless thing known as electromagnetism. Now we can say it is caused by gravity, because gravity is flowing the infinitesimal through the bodies, creating this flow field of the infinitesimal. And if you can imagine many infinitesimal flowing out of one pole, and then another object of relatively same mass having its pole pointing the opposite direction, such that the flows go against each other, there would be a physical turbulence and back pressure from these systems coming together that would ultimately push the large objects apart from one another, thereby producing the observation of magnetic repulsion. Just the same, if the flows merge into one, it would cause an alignment of the large, thereby producing magnetic attraction. So we don't need anything but gravity to explain one of the other fundamental laws of nature. And when we think about it philosophically, why would there be four fundamental laws of nature if there could be just one? It doesn't make sense logically for there to be four, if it would be more simple and elegant if there is just one. So the logical, philosophical view matches with this observation. And that really drives home that this is the model of the universe even before we get into observations. So I will walk us through many observations and demonstrate how this is beyond just all distant redshifted galaxies. But even before then, you should recognize here that this necessarily is, because it is so simple and it does explain electromagnetism, that it must be. But regardless, we will continue on so that you can see all of the observations do match the model. So before we get into the observations, we need to understand what exactly we are seeing. So when we look in the sky, what we call the map of the cosmos is the celestial sphere. And so when we see an object at a certain angle in the celestial sphere and at a certain distance, we will say that that object is placed physically in space that many light years away at that exact distance and that exact angle. And so that object that the light originated from was physically positioned there, where this is lacking the understanding that the great attractor is bending light that is causing changes in the way we observe. So how this works is just the same as on Earth. So imagine the great attractor functions similarly to a cannonball, for example, on Earth. So if we shoot a cannonball, the photons around the great attractor will function in a similar way. And so a cannonball can be shot at a certain angle to arrive at a certain destination, but it can also be shot at a different angle at the same velocity and arrive at the same destination. And so the way this works in the cosmos is a galaxy can shine light at a certain angle that will arrive at Earth due to the great attractor's gravitational lensing, but it can also shine that light at a different angle, and that will also arrive at Earth. And so when we're observing on Earth right now, how we do this is we say there is a galaxy this distance away, positioned at this angle, and therefore it is positioned up here. We say that there is a second galaxy positioned at this distance away and at this angle, and so there is a second galaxy here. In reality, both of these are optical illusions. There is only one galaxy and it is positioned here. And so in the cosmos, we observe what's known as an Einstein cross, where at the center is a galaxy and beyond it is a quasar, where the quasar is light is being bent by the mass of the galaxies by the force of gravity. Instead of traveling away from Earth, it is being bent back towards the observer, and so we perceive this cross in the sky known as an Einstein cross. And so how this would work on the large scale is the great attractor wouldn't just affect one object, it would affect all objects that we observe, particularly ones that are more distant. And so when the great attractor has the photons traveling in a figure-8 pattern through it, it can arrive at Earth at, say, 14 billion light years of travel, when the galaxy could even be literally the Milky Way galaxy if it is old enough, for example. It could be any galaxy. We likely do observe the Milky Way in many of the galaxies that we think are other galaxies because of this effect that the great attractor is doing. So the first observation I want to get into is from Cortot et al. And these researchers, what they did was really fantastic in their mapping of the local universe in the X and the Z plane, and then the X and the Y plane. And what's really exciting about this is called a Wiener filter flow model, although it's under the assumption of the Big Bang, so we have to extract the Big Bang from it and reinsert this model to reinterpret this. And so we understand that logically the great attractor should be bending light into literally its electromagnetic field. And so what we are seeing here is the direction of the bending ultimately, and that is because the flow through, we perceive the poles here, but as soon as it bends off a little bit, it quickly begins to go horizontal instead of vertical. And this is what we would expect if we were actually observing the poles of the great attractor, whereas in the cross section through this, we wouldn't expect to see this distinct polarity with the rapid vertical change, we would expect to see something that was more constant, in that in all directions it's just generally pointing away. It doesn't really matter that there's a pole, it's just generally away from it. And so this distinct horizontal change doesn't really exist as much in this figure. Now we also notice that there is a change here, in that it appears to be looping back towards the Milky Way, but we have to realize that the Milky Way's physical positioning is playing a role in how we're observing this, because ultimately the angle that the light must travel to reach Earth is dependent on the Milky Way's positioning. And so we can see this curvature to it that may or may not actually exist. Now, what's really exciting is there's a cluster, a gravitational anomaly, and thereby not just an optical illusion, a gravitational anomaly known as the Virgo cluster, and it appears to be very distinctly almost bonded to the great attractor in its electromagnetic flow, almost as if they are bonded together by the electromagnetic field. It appears that this actually functions to hold the masses generally in position relative to one another. And so this is very interesting. But this is one of the first pieces of evidence that even alone proves indisputably that this is. But we will continue, because if it is, it should match everything. So the next observation I want to talk about is the cosmic microwave background dipole. And so what this is when we observe in space around us, we observe a non-zero radiative background of microwave radiation known as the cosmic microwave background. And we interpret this in the Big Bang to be the remnants of the Big Bang, but it's not necessarily that. It could also be just the infinitesimal, because as we understand, the universe is infinite in size, and so as it shrinks, the space between it isn't just emptiness, it is infinitesimal, filled in, and this ultimately produces an ether that we observe the highest infinitesimal of, and that produces a near uniform ether known as the cosmic microwave background in the microwave radiation. So we observe this, and this is ultimately equivalent to the galactic halo of the great attractor. Now the dipole is a redshift and blue shift anomaly that we observe, and ultimately what's really telling about this is the following. So the way we observe this is a 3D image. So Earth, looking in one direction in space, sees a blue shift in the cosmic microwave background, and looking in the directly opposite direction through the Earth, so to speak, on the opposite side, we observe a redshift. And what's really telling is that directly at the center of the redshift here is the great attractor. And so light coming from the great attractor to Earth is being gravitationally redshifted, and light coming towards the great attractor that arrives at Earth is being gravitationally blue shifted. And this is occurring more and more as it becomes more and more directly towards the great attractor in its flow pattern. And so more and more of a percentage of its flow is being red shifted or blue shifted. So this figure matches the expectations that we would have from gravitational redshift. But beyond that, this image also proves once again that this is due to gravitational redshift, because we observe here this is a spot, this is a redshift anomaly where the local area around it is more blue shifted, and so we would expect this to be more blue shifted, but it is more towards the red spectrum, and so this is a redshift anomaly. So too is this. We would expect this to be more flat. This is also a redshift anomaly, and this is also a redshift anomaly, and we see in this line, it's a linear relationship. These are all in one plane, almost as if they're coming from one source. And so if we remember, one source can cause two observations, particularly when the great attractor is causing this. And so the great attractor, we're only going to see one, but the other source, this source, we're going to see two. And so what we see is that on one side of Earth, this source is producing two redshifts due to gravitational lensing, and on the opposite side of Earth, it's producing two redshifts again, and this is because ultimately it is gravitationally lensing the light around the great attractor, which allows for light here to travel further while under the effects of the great attractor, thereby producing another redshift anomaly because it is much more proximal to the great attractor. And so we perceive four redshift anomalies, which simply could not be the result of Doppler shift. These are definitively due to gravitational lensing, and therefore these are definitively due to gravitational redshift. So the next piece of evidence again is from Courteau et al. And in the local group, we see in the X and the Y plane here, at the center is the Milky Way, and each of these are galaxies in the direction of the great attractor. The light coming from the galaxies in the direction of the great attractor is being redshifted as the light moves away from the great attractor, and this is largely on this dichotomy of the half of the local groups are redshifted, whereas the galaxies in the opposite side, where the light is moving towards the great attractor, the light is largely being blue shifted. And so the reason this is happening is because this is caused by gravitational redshift. Now, as the distance increases, though, beyond the local group, that's when the great attractor's figure 8 pattern has played its hand substantially to a point where then all galaxies are redshifted, such that even if they're over here originally, it only plays a small role, and then it is all redshifted beyond that certain distance. And so this matches what we would expect with gravitational redshift, and thereby further evidences that this is the model of the universe. The next observation I want to look at is again from Courteau et al., who mapped again the local group, and we see the great attractor is at the Centaurus cluster here, and each of these are known as superfilaments, which is essentially where galaxies appear to prefer to exist. So what's interesting about this is we see that there's not just some random number, there's 1, 2, 3, and 4 superfilaments coming from the great attractor that wrap around the Milky Way, around the Earth. And when we look directly in at the great attractor here, and this is from the video of Courteau et al., which I will link below, when we look directly in on the great attractor, we observe this structure that almost looks like it is a moving Einstein cross in the sky, at where you can essentially dissect this at any point and arrive at an Einstein cross. And so this is a very odd observation to be making if it's not related to gravitational lensing. Now, what's really telling here is the following, these four clusters. So again, an Einstein cross is four, so the significance of four with regard to gravitational lensing is extremely important. So what we notice when we look directly in at the great attractors, these four aren't just randomly structured, they form an Einstein cross in the sky of these four galaxy clusters. And so these aren't just different galaxy clusters. These are each the same galaxy cluster at a different time because its light had to travel at different angles and thereby different distances it had to travel, and thus we're seeing it at different times in its lifespan. And so we can perceive the same galaxies at different times and know that they're the same galaxies because gravitational lensing is playing its hand here, producing these optical illusions of what is around us. And again, this is an indisputable piece of evidence in and of itself, but when taken together with all things, we see that this is. So now we've removed expansion of space and cosmological redshift from the model, and we've removed electromagnetism as a fundamental law of nature and shown that it is the result of gravity. So we'll continue now by looking next at dark energy. So dark energy is something that was added to the model after we observed the accelerating rate of redshift per distance. And so this was interpreted to be the result of dark energy, thereby adding to the model. And so what dark energy does in the Big Bang model, it causes the rate of expansion of space to accelerate. And so we understand that expansion of space is unnecessary. So we want to see if there is a simple answer for how this is happening in the universal principle of natural philosophy. And so just to quickly look here, Hubble's law is redshift per distance that is linear, but as that distance increases, this relationship begins to become more and more exponential. And so this is what is occurring, is an accelerating rate of redshift per distance. Now we'll show that this accelerating rate of redshift per distance is the result of gravity by understanding first and foremost that a redshift in the light spectrum is a physical reduction in the velocity of the photon. It is one that we as fallible observers cannot perceive, but it is occurring. There is a reduction in the velocity. So, in knowing that, we can now look at the figure 8 pattern and remember that if a photon, let's say arbitrarily, starts at 0 redshift, we'll say here, when it goes through one of the figure 8 patterns, when it arrives back at the center, it will have undergone a red shift and thereby a reduction in its velocity. And so when it comes out the other side, just the same as if you throw something in the air, with less velocity, it won't go as high, and so this won't go as far, and then it will be redshifted again through the motion, and each time through it will go less and less far away from the great attractor. And because the force of gravity is an inverse of radius squared, the closer the object is to the great attractor, the higher the force of gravity. And so therefore, the closer in radius the object is when it goes through the orbital motion of this figure 8 pattern, the more the force of gravity is, and thereby the larger the gravitational redshift effects per distance. And so we would anticipate with this model to see a relationship of redshift per distance that begins essentially linearly along a relationship of Hubble's law alike to this, and then begins to accelerate. And that reason is because it is an exponential of r squared. So as radius shrinks, the force of gravity increases exponentially because radius is shrinking, thereby producing an accelerating rate of redshift per distance. Therefore, we can answer this observation of accelerating rate of redshift per distance without adding to the model, only using gravity to explain this. Therefore, again, this proves to us that this is the model of the universe because it is so simple and explains the observation. Now, dark matter is a hypothesized kind of matter used to explain gravitational effects observed in the cosmos. And so we understand this is simply the infinitesimal that is in orbit or traveling around the systems that we observe that are large enough for us to observe, but the infinitesimal are unobservable. However, their mass is causing an observation of gravitational effects. And so, of course, this is what we are observing. Dark matter is real, it is just the infinitesimal around us. And so now that we've explained away expansion of space and dark energy, as well as explained how electromagnetism is caused by gravity, we should revisit the question of why are there 4 fundamental laws? Why isn't there just one? So the 4 fundamental laws of nature are gravity, electromagnetism, which we've shown to be the result of gravity, and strong and weak interaction. And so strong and weak interaction are used to explain only the atomic, only the small scale. We don't perceive this on the large scale, and so if there's only one, it is gravity. And so in order to understand how strong and weak interaction are the result of gravity, we must recognize first the necessity of the universe to operate under a principle of correspondence. If this is the model of the universe of the infinitely large and infinitely small, what that means is that all levels of the universe are observably the same dependent on the observer. So we're on one of the infinite number of levels, but if we were on another of the levels, we wouldn't be composed of atoms. We would be composed of the level below that level, which is ultimately the highest building block on that level. And so, for example, if we lived on what we would call a black hole, if we called that our planet, we would call what we call solar systems atoms. We would call stars the nuclei of atoms. And so this parallel that all things must be all things should exist if this is the model of the universe. So we can look to see if the universe functions such that, for example, planets are stars, that solar systems are galaxies. If we can show that, then we will show that this is the model of the universe. So, is the solar system a galaxy? So how we do this is we look for generalizations. We can say that a galaxy has some center of mass that we observe because we are made of atoms as a black hole. It has an orbiting mass of the disk of the galaxy, and it has what's known as the galactic halo, a sphere of dark matter around the galaxy. And if it is a spiral galaxy, one of the three types of galaxies, it has an arm structure. And so this is a generalization that we can make that we would expect to perceive in other levels of the universe. Now we have to note that the way that we observe these things would be different due to time dilation. The larger the object, the slower the function. And so we would expect to perceive certain events that occur in the large that take many years to occur. We would expect to see them essentially instantaneously in the infinitesimal. And so there would be observed variances such as this due to time dilation and due to the fact that we are composed of specifically atoms, and we ultimately use atoms to observe all things. So, does the solar system have these things? The sun is, of course, the center of mass. The planets are orbiting mass, but so too is the asteroid belt and the Kuiper belt. And so there is an orbiting mass that we would expect to be perceivable as this disk structure, particularly the Kuiper belt, which is much larger and composed of many tiny particulate structures that could be perceivable as this disk structure around the sun. The solar system also has what's known as the Oort cloud, which is a sphere around the sun where ultimately comets and other such objects can come from, and is composed as well of dark matter. And so again, it has a galactic halo. And what's really telling about this is that the solar system also has arms in what's known as the heliospheric current sheet. And what this is the sun, when it rotates, its electromagnetic field produces waves such as this in the current sheets, and this wave to an observer on a lower level of existence would then manipulate the Kuiper belt into being observable as the disk of a spiral galaxy, and so the solar system is a galaxy. And as soon as we see that the solar system is a galaxy, we understand that this pattern must continue logically. It doesn't need anything more. But because we recognize that this is, we should be able to perceive connections in all systems. And so we continue on. Does the Earth system have this structure? Well, the Earth would be the center of mass, but interestingly, beyond just the moon, which would be equivalent to a satellite galaxy orbiting about a galaxy, the Earth also has what's known as the inner and outer Van Allen belts. And so these function as the inner, the asteroid belt, and the outer, the Kuiper belt. And so we see two belts just the same as we see in the solar system. And so we see that the Earth functions in the same way. Now, the problem with the Earth is as we begin to get smaller, it's harder to perceive all of these generalizations. So we don't say that the Earth has some equivalent to an Oort cloud or to a galactic halo, but gravity would necessitate that it does, because gravity pulls matter around it and creates a steady state that would ultimately be the Oort cloud, the galactic halo. The Earth also has an electromagnetic field, and as the Earth rotates just the same as the Sun, this would produce a spiraling heliospheric current sheet that would manipulate to an observer on a lower level of existence the Earth system's outer Van Allen belt into being observed as a spiral system of a spiral galaxy. And so the Earth is a galaxy. The Earth system is a galaxy. But we can continue because we see that if this is true, then everything that is this generic thing, the center of mass, should function the same. So the sun should be alike to the earth, and the earth should be alike to the sun. So we can continue looking for these patterns by saying, are the sun and the earth the same? So the first thing we want to look at is the sun, which is more massive than the earth and therefore would pull in more radiation at a higher velocity ultimately. The sun emits radiation in the visible light spectrum, but the earth, being less massive, it doesn't emit visible light radiation. It emits infrared light radiation, and this is just a function of its mass. So because it's less massive, it produces less radiation, but the fact that it radiates is, and so we see again another connection. The sun has what's known as the photosphere, which is essentially the edge of where the sun glows. The Earth also has the equivalent of a photosphere, which is known as the air glow of the ionosphere. And so the Earth glows, so to speak, to the edge of the air glow, and then we perceive a limit just the same as the photosphere, and this is the equivalent of the photosphere, and this is evidenced by the fact that sunspots exist at the edge of the photosphere, and then solar flares will come from these sunspots, and this is an observation that we make. So if this is on the sun, we should perceive this on the earth. And what's really exciting is that when upward lightning strikes, what occurs is it goes through a disk structure that forms at the edge of the air glow, just the same as sunspots at the edge of the photosphere. It goes through this disk structure and then will bend back due to gravity. Now this is a lightning strike, so again we have to realize that time dilation is playing its hand. So we're perceiving this as being essentially instantaneous, whereas on the sun we perceive this as taking time to pass, as a solar flare does. But we realize now that this correspondence does exist. So with this in mind, we can move back and say, well, does weak and strong interaction, which only occurs on the atomic scale, also occur in the cosmos? So what these forces are responsible for is radioactive decay, nuclear fusion, and ensuring the stability of ordinary matter. So this ultimately is just all of the atomic functions. And we want to see, do we see these functions in the cosmos? So the way radioactive decay works is a certain mass will release radiation and become a smaller mass at a new stable point. And what matters is this isn't just slowly occurring over time. This occurs instantaneously. It's very spontaneous when it occurs. So what we need to look for in the cosmos is something that is spontaneous, in that it suddenly occurs. So radioactive decay in the cosmos can be found through understanding that supernova are spontaneous, and the luminosity of an upper limit mass star, one whose mass is so high that it just quickly supernovas because it's unstable at that mass. These stars, when they supernova, we literally measure their luminosity as the result of radioactive decay of the atoms within the star. And so we make this connection of radioactive decay to supernova, but we didn't have the principle of correspondence to realize that we are literally observing radioactive decay when we observe the supernova of an upper limit mass star. So nuclear fusion is when two masses will come together and form a new larger mass, but release a portion of the mass and a portion of the mass as energy ultimately. And so this occurs only at a specific point where it always releases the same amount of energy dependent on what the particles are. And so what is significant here is there is a specific amount of energy released whenever these two systems are combined. Now, in what's known as a supernova type 1a, what occurs is two systems combine into a new system when the larger mass system reaches this point of instability due to drawing mass off of the other system, it then supernovas, releasing radiation at a very specific amount. And so this is why supernova type 1a are used as what's known as a standard candle, where ultimately we view the supernova, and because we know that it is a supernova type 1a and we observe its brightness, we can determine its distance based on the known luminosity. So based on its brightness, we can say it is this far away, and this is what it means to be a standard candle. And the reason it is a standard candle is because it always releases the same amount of energy, because it literally is nuclear fusion, just the same as how nuclear fusion always releases the same amount of energy. Now, quasars, these are a compact region in the center of a massive galaxy that surrounds its supermassive black hole. And this is extremely luminous and energetic, and the energy emitted by a quasar derives from mass falling onto the accretion disk around the black hole, and these are always found at the center of new young galaxies, not any galaxy, but new young galaxies. And the reason that is because they represent the formation of new young atoms. Literally, they represent that, in that it is just a larger level of existence coming into being. Now, this is further evidenced because the closest quasar is directly towards and near the great attractor. And the reason that is because as you approach the great attractor, the density of the material in the local vicinity begins to increase. And what occurs is then structures that didn't have enough mass to become stable at that size are now able to be formed, because there's enough mass that the steady state of that system can be reached. And so larger structures are formed around the great attractor. And so this is why the closest quasar is near the great attractor, and there aren't any near us because the density around us isn't high enough for us to observe local quasars. So with this in mind, we've used reductionism in an infinite, eternal, fractal universe, one that is infinitely divisible into smaller fractals. We've used this to explain that the universe is infinitely large, infinitely small, being manipulated by gravity, period, and that is it. And this is further evidence because gravity, which is an inverse of r squared and causes other observations, isn't the only inverse r squared function. So too is electric, magnetic, light, sound, and radiation phenomena. So all of these are functions of inverse r squared because they are functions of gravity. Now I want to quickly talk about light on the infinitesimal level. So as we understand, stars supernova very rarely, and we don't perceive that occurring very much. But if you can imagine that all around us were to be sped up so that we could perceive almost instantaneous supernova of all systems, then we would begin to perceive the pixels of reality around us such that it would form a new image. And this is what a higher level of existence may be perceiving, is those supernova going so extremely quickly. So just the same, when we observe the infinitesimal, all it is just systems that are so rapidly flowing through instability cycles that they are constantly in supernova, and the larger systems are when there's sufficient amount of energy, those systems then can radiate energy that we actually can perceive. So it takes enough input for us to then perceive the higher systems supernovaing all around us. And so all things come down to the supernova of the infinitesimal. Now, how this works in terms of redshift and blue shift is very simple. If you were to take just a block of light, say there is a portion of light that is filled in this volume of blue light, but if you were to take that same light in this volume and stretch it into a larger volume, it wouldn't still be blue. It would reach a new steady state. The infinitesimal systems within that would begin to shrink down to a new steady state. And this then causes us to perceive those systems as a new color. And as you stretch this, the mass into larger and larger volumes, you can ultimately move through the spectrum of light. And so at the end of the day, all radiation is mass per volume, period. So how this works in terms of gravitational redshift, so for example, if this light is moving away from a source of gravity, and the source of gravity is further away from this side than from this side, the force of gravity would be larger on this end than it is on this end. And so this end would begin to slowly creep away such that it stretches. And so what's occurring is that this is moving faster than this due to its proximity. And this stretches the mass per volume into a new larger volume. And so this is redshift at the end of the day. And so this is causing redshift due to the slight change in velocity change that stretches the mass per volume. And just the same, if you have a red and you shift it into blue as the object moves towards the source of gravity, the portion that is further away can actually speed up more than the portion that is closer to the source of gravity, because the portion closer is closer to the limit of motion of matter, unless it doesn't speed up as much as the other end, unless this can be shrunk back down to the smaller mass per volume when it's moving back towards the source of gravity. So when it comes to absorption lines, ultimately this is just where those particles in the infinitesimal are. If they're a certain wavelength, it's because they're a certain mass that is slightly varied from the other masses that we also perceive around them, that we ultimately approximate as all the same because they're all essentially zero in our eyes. But these are slight variations in the actual mass, and so dependent on what the mass is, certain other masses will be absorbed into that system. Otherwise, they may flow through the system and not be actually absorbed. And so this is why we see absorption lines as we see them, because it's based on the different levels of the infinitesimal that are so close to one another in mass that we can't really perceive the differences, and so we approximate things as being constant and under certain patterns, but we're ultimately just drawing approximations that allow us to understand and utilize our understandings better in ways that come down to chemistry, for example. So real quickly, just in this image, if you imagine that the sun is shining down on this hill in the Grand Canyon here, if the sun is shining on this portion, the electrons within the atoms are absorbing radiation from the sun, and those are then supernovaing dependent on what they are precisely, and this produces different wavelengths of light that we perceive as all of the different colors. But as soon as the sun goes away, the new steady state of the system is quickly reached because it's so instantaneous in our perceived time dilation that it just immediately occurs. And so that's why a shadow is immediately formed when the light moves away. It doesn't have this delay. It immediately occurs because the infinitesimal is so quick relative to us that it just is instantaneous. For example, when we turn a light off, the room isn't glowing for a few seconds. It is just instantly dark, and this is because of this. So ultimately, what we need to realize, and you can see this if you look around you, you can actually see it if you look for it in the right lighting, particularly like a dimly lit white wall, for example. You can see all of the infinitesimal. If you look in the right way, you can see tiny pixels of reality shimmering in these images because we're actually seeing the infinitesimal vibrating through these cycles of instability, through supernova and supernova and supernova, so quickly that it essentially forms this real image around us that we then can translate into what reality is, as opposed to just being darkness with random stars sporadically placed. Now the next thing I want to talk about is heat. Heat is just the same as light, it's just instead we perceive this as temperature, as something we touch, feel, as opposed to something we see, we visually see. And so it's just a different form of the same phenomenon of mass per volume. So for example, when we turn a microwave oven on, what we are doing is we are shining the infinitesimal into the atoms of the food, and it's not enough energy to change the atoms, it's just enough to change the infinitesimal around it such that it approaches a higher level of steady state, and that's what we then perceive as temperature, is this new steady state of the infinitesimal within the atoms. Further, this can be shown in the electric stove. So how this works is the coil has an electric current flow through it, but then there's a resistor that limits that current, thereby producing ultimately a buildup of this electrical current. And so because it's building up, it begins to search for different paths of least resistance, and then it can begin to radiate outward as entropy. And this is how we cook our food, is through the radiation of the infinitesimal out from the coil of the electric stove, thereby producing heat, again just producing more mass per volume. Now the last thing we can look at is superfluidity, and this is a state of matter in which the matter behaves like a fluid with zero viscosity, where it appears to exhibit the ability to self-propel and travel in a way that defies the forces of gravity and surface tension. This occurs as temperatures approach 0 Kelvin. So we understand that temperature is linked to the physical mass of the infinitesimal within the system. So as we take this system and we remove the infinitesimal such that there is no mass around it, we're removing the actual mass from the system, and this changes the way that gravity interacts with the object. And so, for example, the atoms along this wall will feel this gradient in local gravity much more than if they're in a normal temperature, and so they will begin to flow due to local gravity variations up the wall, and then they will fall back down the other side once they get over, and this creates this dripping, and this is known as superfluidity. This is because of the way that the change in mass causes the system to act due to gravity. It's not defying gravity, it's just changed in a way that gravity affects it strangely. Locally, it is much more dominated by this proximal system. So some other observations I want to get into are the other two pillars of the Big Bang. So the first two are the all-distant redshifted galaxies, and the second is the cosmic microwave background. The third is the high abundance of light elements in distant galaxies. So the further we look away, the higher the abundance of hydrogen and helium, etc., in those galaxies. And so that's one, and the other is galaxy evolution. It appears that galaxies have evolved over time. And so under the Big Bang model, they say this therefore means a beginning. But it doesn't necessarily mean that. It just means evolution. It just means that a flux in the system is occurring. So in order to understand how it's just change, it's not that there was a beginning and before the beginning there was nothing. It's just change within the things that already existed. We can look at entropy to understand. So entropy is thought to be the universe's tendency towards chaos, towards disorder. But we realize that radiation is just infinitesimal mass. And so this mass doesn't cease to exist. It's just recycled into new systems, into new electromagnetic fields, and it can be recycled into even the same system. So entropy isn't the universe's tendency towards chaos, it's the universe's tendency towards change, towards renewal, towards evolution. This is how the universe functions. So yes, we would expect to see a high abundance of light elements in further distant galaxies because they have evolved over time, because those systems are older than they were. So yes, we would expect that. That is exactly what we would expect, but it doesn't mean that there was a beginning. It just means those systems have aged and are beginning to progress towards later stages in their lives, and they may cease to be and then come back into existence, etc. But ultimately, this doesn't mean that there is a beginning. The next observation I wanted to talk about is pulsars and black holes. So because we understand that the electromagnetic field is actually photons, etc., is the infinitesimal, then we can understand that as the mass of a system gets higher, it would affect certain wavelengths, visible light, in different ways. And so if the mass is small, visible light can go further away from it than if the mass is large. So as this mass increases, the distance out that visible light can go decreases. And so as we're further away from the system, we can begin to perceive that system as, instead of being a star, we will perceive it as a black hole, because its light is bent back in on itself such that none of the light reaches us. But because the light is flowing in an electromagnetic field, if we're close enough that we can see the poles where the flows are largest, but we do not see the sides of the star where the flows are smaller, then we will perceive that object as a pulsar. And so that is what a pulsar is a black hole that we are close enough to that we perceive the poles. So you have to realize that black holes aren't singularities, they're really large in size, but we perceive them as singularities because they are so massive that they bend all visible light back in on themselves. But if we perceive a black hole in the X-ray spectrum, because it is at a higher velocity, it will go further away from that black hole, and thus when we look at a black hole in the X-ray spectrum, we perceive this almost photosphere of the black hole because it is the photosphere of the black hole. We're actually observing the black hole more as it is, really, really large in radial size, not just a singularity. It is extremely massive and large in volume. It's not even remotely a singularity. It is the complete opposite. So we have to realize that black holes aren't singularities, they are just illusions caused by the way that gravity plays with light at different wavelengths as masses get larger. Now, quantum entanglement is what's known as spooky action at a distance, where two quantum particles can appear to interact with one another at speeds greater than the speed of light. And the reason that is because they are just the infinitesimal that were already gravitationally locked to one another. And then we pulled them apart such that they maintain their momentums, so we can then say, well, this one was doing this, so that one is doing that, without actually looking at the other. And so spooky action at a distance is just us perceiving this that was already known to the object. We are just perceiving it, and thus we're seeing that both systems necessarily follow what the other system was. It's not in any way communicating with that system anymore. It's just that they already had the knowledge before they were separated. Now the next thing I want to talk about is life again. So quickly, just to go into this, as I've already talked about it a little bit, there are an infinite number of levels. We are on one of the infinite levels, but it's just an arbitrary level. We call this level planets because it's where we live. We call the level below us atoms because this is where we live. That is the building block, the largest building block that we perceive that makes up what we are. So that's the level below us. But if we lived on any of the other levels, we would look at that level and all the adjacent levels as the same structures as those that we now look at. And so it wouldn't actually affect us in any way. Time dilation would play a hand such that if we unobservers here were to move onto a smaller plane of existence and then to live, our entire lives would pass in what we would call an instant on this plane, but it would be an eternity to the observers on that plane. And so what we call life could be literally anywhere. It doesn't have to be on a planet, on a system such as ours. It could be literally on the sun, and we wouldn't even know about it because it's composed of a different building block that thereby affects what it would be a comfortable, reasonable living standard in terms of temperature, radiation, and etc. It all comes down to what is your building block actually affects which radiation you're capable of being in. And so there's no way for us to actually perceive these other things, but around us at all times, entire civilizations are passing. Everything that is, was, and ever will be could be passing around us instantaneously at all the time, but we just simply wouldn't perceive it because we are finite, fallible observers. So the next thing I want to talk about is known as the expanding Earth theory. The current model of the Earth is known as plate tectonics, where each of the continents is on a plate and they slide around, and the sliding of the plates can push up mountains as well as create earthquakes. And so this is the current theory. It is not a fact. We have to be open to all possibility. So what's really interesting about the expanding Earth theory is that the system known as Pangea, where the continents were all formed together in one landmass, this system assumes that there was an ocean at the time. But if you were to physically shrink the system back, all of these parts can actually come together and thereby produce a physically smaller mass that actually fits together. And the reason this is happening is because it was a physically smaller mass. Now, even though to an open-minded person this is irrefutable evidence, we can continue by looking at the base of the ocean where the crustal age has been taken, and what they found was along the cracks the age is actually much younger than further away from the cracks. And so if you actually remove the layers, what they did is just over time they removed time and shrinked the earth back down, and they find again it shrinks back down into this system. And so because of it's not even a question, it's just a matter of how this is happening. In the past they said, well, we don't know how, and so they discredited this theory and ignored it because they thought, well, the earth can't just expand, this doesn't make sense. Well, yes it can, and how it does that is that there is a flow of mass of radiation into the earth, and when that flow in is greater than the flow out, then necessarily the system will grow. The probability of the infinitesimal within the earth interacting with the other infinitesimal and forming into atoms increases as you increase the mass in, thereby actually producing mass. And so when we don't understand where all of the water on Earth came from, this is why. It's because we don't realize it is being formed physically within the Earth. So, for example, sulfur vents at the bottom of the ocean where sulfur is coming out. It's not just sulfur. Water also is formed in the earth and is being vented into the oceans. And so this is producing the ocean. It's not from comets. It's not from space where the water came from. It's from the influx of energy that causes an influx of creation of the larger levels of existence, thereby creating, for example, hydrogen and oxygen, which are lighter atoms in a higher frequency than the other atoms, and thus the earth will become over time largely water because of this. And so this is, and the how of it is now explained. We don't need to say that this doesn't make sense because of the how. So plate tectonics, which is a theory, doesn't stand in the face of this evidence. This is. So the next thing I want to talk about is known as the double slit experiment, which has a paradox known as the witch path observer paradox. So how this works is light is shined through a double slit design, and each of the slits produces a wave pattern, and the two waves interact with one another such that they either add or cancel, producing what's known as an interference pattern such as this. So an interference pattern is specifically the result of waves, whereas a particulate pattern would be one in which the particles flow through the slit and then they produce individual particulate patterns, such as if you threw a baseball through a slit, it could only go at a certain angle and it would only produce two portions where it can possibly arrive at. And so it wouldn't arrive at an interference pattern, it would arrive at a particulate pattern. So when we then try to observe, well, which slit is the particle going through, when we do this, we can change the pattern from an interference pattern to a particulate pattern. And so this is known as the which path observer paradox, which only occurs when there is this quote observer. Now we understand that gravity causes everything, and so this must be the result of gravity. The only way that this can be the result of gravity is if the slit itself is playing a role in producing the wave pattern. So because the slit is small enough, only a small percentage of the particles can go straight through the slit without being deflected by the force of gravity of the slit. So when the particle is deflected, whenever it's off of the direct center, the further off it is, the more it's deflected. And so this arrives at a wave pattern in each of the slits. So when we observe which slit the particle went through, what we are doing is shining energy into the slit. We are actually affecting the local gravity such that the slit's effect on the particle is less, because there is radiation now in the slit that is causing the particle to not be quite as affected by gravity, as well as we are adding mass to the particle such that it becomes excited, so that then it releases radiation so we can see where it is. So we're adding a lot of mass to the particle, which would also cause it not to be deflected quite as much. Therefore, this effect would turn what was once a wave into a particulate pattern. Now this is evidenced by the single photon experiment, where they shine single photons through the double slit at random, and they'll arrive at various locations, but over the course of shining many of these photons through, even though they're single photons, they will sum up into a totality of an interference pattern, because gravity is bending the light. So how we can prove this is extremely simple, and anyone can do this at home. So because the slit itself is playing a role due to gravity, then we can change the force of gravity by changing the atomic mass of the slit. So if we use different materials, we'll find that the different materials will deflect the light into higher intensity at different widths, at higher masses. So if we use carbon, it might only bend it at a certain angle, but if we use steel, it might bend it at a higher angle. And so we can simply test this by just adjusting the mass of the slit and trying to have the same general settings, so the same width, the same surface roughness, the same diameter of the slit components, etc. We can adjust the system such that it is the same, except for the change in the molecular weight of the building blocks, and thereby we can see its effect of just purely mass on the photon. So how we do this is very easy, and I understand that this isn't very scientific, but I just did this with a cursory look so that we could just demonstrate that this is, all of the evidence supports it. This is unnecessary to do, but a cursory look shows that this is. So what we can do is use 3 pieces of pencil lead, which is made of carbon, of graphite, and we can form this slit experiment with 2 slits between the 3 pieces of lead, and then we can use a comparably sized, higher molecular weight slit structure, such as what I did here was use some guitar string and produce this double slit, and then we can shine the light through it, and what we would expect is the deflection angle of the light in the carbon double slit experiment would be less, such that it only has a certain width of deflection, whereas the steel we would expect it to deflect much wider, and so we would expect a much more intense light out to higher distances than with the carbon. So when we do this, and this is hard to see here, but there's an interference pattern on each of these which shows that it is the result of the double slits bending, creating the wave. When we do this, we perceive that the width of the carbon is much less than the width of the steel's deflection, thereby proving that this is the result of gravity, and that therefore all other things that I've said this is the structure of the universe. This is the theory of everything. This is the universal principle of natural philosophy. And so, with that in mind, we can now come to say that the material universe consists of infinitely divisible mass in infinite volume being manipulated by gravity. And I use the words consist of because we don't need anything but this to explain the entire universe. This explains everything. And so this brings us to the question, because we understand that mass is ultimately a function of gravity, and therefore gravity is essentially all that is. This brings us to the question then, what is gravity truly? And we see that gravity manipulates the universe into being. Gravity literally creates the universe. So in other words, in my next video, we're going to ask the question, is this scientific proof of God? So thank you for watching my video. I really appreciate you taking the time to watch, and I hope that this helps you open your eyes to the reality that is. And in my next video, we will certainly begin to follow through with what this really means, because when we finally understand the material universe in its entirety, that is when we can expect to understand the spiritual aspects of God as knowledge, as not just beliefs, but we can then come to know the reality that is. If there is a God, this is when we would find it. So the fact that we are finding this concept that perhaps gravity links into God as perhaps a way that God creates the universe, or that gravity is God, will show that it isn't, but as perhaps a way that there is an argument that God is, then we're going to have to face all of the realities that this brings to us, because this is when we can know that God is, and then we can change our lives bring that knowledge into our lives, and we can transform this world into what it's meant to be. So thank you for listening, and I look forward to where this takes us. Thank you.